Light from a laser is not like ordinary light. It is sharper and more focused. All around us in our everyday lives, we use laser beams as tools, from commerce to entertainment. Have you ever wondered what a laser really is and how it works? It's all about carefully coordinated interactions between atoms in a material and particles of light called photons. Here's ordinary light, like that from a bulb in a flashlight, a desk lamp, or the sun. The photons behave as individuals as they move, with no coordination. Now, here's laser light, where instead, the photons' movements are coordinated. So how do we get light to move like that? First, we need a special room. The far end reflects the light particles perfectly, while the near end, where the laser light will emerge, reflects about half of the light that hits it. The light that escapes the room in this way will be our laser light. But we need one more ingredient to produce this light. We place in the room atoms. The atoms absorb the photons from an ordinary light source that is shown into the room from its sides. The atoms are now in an excited state, having paired up with their photon partner. Not all of them have to get excited, just most of them. Some can remain unpaired. The situation where most of the atoms have absorbed a photon is called population inversion. Sometimes an excited atom will randomly eject a photon. The photon is likely to meet another excited atom, stimulating it to eject its photon, and the photons move off in step together. This is called stimulated emission. One photon will leave the room when they hit the front wall, while the other reflects to return to stimulate another emission. Imagine this happening all over the room. This interplay between photons and atoms gives a stream of coordinated light we call the laser. The atoms get excited by ordinary light, and random ejected photons trigger a chain of events. They stimulate atoms to emit more photons that move just like them. Some escape to form the laser beam, while some reflect back to stimulate more atoms to emit more photons, some of which form the beam, while others trigger more emissions, and so on and so forth. This is light amplified by stimulated emission of radiation, laser. Lasers are also used as scientific research instruments, for example, in the study and design of new chemical compounds and materials. Next time you see a laser in use, now you know what's really going on inside.